Now let us solve the system given here. So we will have a 4 equations in 4 unknowns. So the first thing that we need to do to solve the system of linear equation is to form the augmented matrix, right? So we simply get all the coefficients of the variables x sub 1, x sub 2, x sub 3, and x sub 4 being 0, 1, 2, 1. And then you also have here your 1, 2, 4, and negative 4. And okay, what else? We have here for your third column, you have 1, negative 1, 1, and negative 7. And then you have negative 2, 0, negative 3, and negative 1. And finally, the last column being the constant terms. So again, in order to apply the Gaussian elimination, we will be applying the 3 elementary row operation. That is, we can interchange rows. We can multiply a row by a constant, and we can also add, let's say, a multiple of a row to another row. So notice that in our augmented matrix, we do not have the leading one. So since the second row has 1 as the first entry, what we can do is to interchange row 1 with row 2. Now we need to convert 2 and 1 to 0. So what we can do now is to multiply row 1 by negative 2 and add it to all the entries in row 3 to form the new third equation, to form the new third row. So here, if I multiply this by negative 2 and add it with row 3, you have negative 2 plus 2, we have 0. Negative 2 times 2 will be negative 4 plus 4, that will be 0. Negative 2 times negative 1, that will be positive 2. 2 plus 1 is equal to 3. Negative 2 times 0 is 0 plus negative 3. We have negative 3, and negative 2 times 2 is negative 4. Negative 4 plus negative 2 is negative 6. Now, we already have a 1, 0, 0 here. We need to convert this to 0. And we can still use row 1. Say, if I multiply row 1 by negative 1 and add it to all the entries, say negative 1 of row 1, adding that one to all the entries in row 4, we have negative 1 plus 1, this will be 0. Negative 1 times 2 is negative 2. Negative 2 plus negative 4 will be negative 6. Negative 1 times negative 1 is positive 1. 1 plus negative 7 is negative 6. And negative 1 times 0 is 0 plus negative 1. We have negative 1. Negative 1 times 2 is negative 2 plus 19. Negative 19 is negative 21. So this one, we were able to have a good start. So we were able to convert all the numbers below 1 to 0. And we will have here the next leading one, which is the coefficient of the second variable. Now, since we already have a 0 below it, then we only need to convert negative 6 to 0. So what we can do here, we multiply the entries of row 2 by 6 and add it with the entries of row 4. We have 6 times 1 is 6 plus negative 6. This will be converted to 0. 6 times 1 is 6 plus negative 6. This will be converted to 0. And 6 times negative 2 will be negative 12. Negative 12 plus negative 1. That will be negative 13 now. And 6 times negative 3 is negative 18. Negative 18 plus negative 21 is negative 39, right? So this will be the new entries for your row 4. Now let us see the next slide. So we have here 1, 0, 0, 0, and then we have 2. And then we have changed all the numbers below the next leading one to 0. And we have, for the third row, we have 3, negative 3, and negative 6. And for the fourth row, we have 0, negative 13, and negative 39. Now, we can actually simplify row 3. say if we multiply row 3 by 1/3, okay, then this one becomes 1. Negative 3 times 1/3 becomes negative 1. And we have negative 6 times 1/3 becomes negative 2. And then we already have a 0 below that one. So see here that we have the first leading one at the topmost left corner. And then below that one are all zeros. And then we will have the next leading one as this, which is the coefficient of the next variable. And below that one are all zeros. And then we find the third leading one here. And below that one is also 0. And then we find the next leading one, which is this. Consequently, we know what the last row means. According to the last row, that we will have 1 times x sub 4 is equivalent to 3. Okay? So that row 4 simply tells us that x sub 4 is equivalent to 3. And we can now apply our back substitution to solve for x sub 3. And then once we know x sub 3, which is simply negative 2 plus 3, which is positive 1, we can now apply back substitution again to find x sub 2. And once x sub 2 is obtained, we can now find x sub 1. Now let's see what are the answers. Okay, so we have here x sub 4 is 3, x sub 3 minus x sub 4 is negative 2, x sub 2 plus x sub 3 minus 2x sub 4 is equal to negative 3, and you will have x sub 1 plus 2x sub 2 minus x sub 3 is equal to 2. Okay, applying the back substitution, we can see now that the solution is contains the following coordinates. We will have negative 1, positive 2, positive 1, and positive 3. And since we only have one solution, the system is said to be consistent independent.